Okay, in last video we understand the concept of groups and membership assigning of different users in different groups and how we can allocate some specific users and specific group with some specific project, and then we can assign some roles on that specific group, and all the users will be able to have access that role. Now we have to understand in this video two important concepts. The first one is in that OCRSH command. How this command is you can compare with the OC execute. And second thing, we have to understand the certificate authority that is by default running in cluster, and we can sign some certificates to deploy in the application. If we want to deploy some certificate at the pod level, just like our API server and Scalar and etcd, they all are using the certificates, and there is a centralized signing authority, certificate authority, that is responsible to generate all those certificates. So we can use the same certificate authority to generate our own certificate. So first of all, understand this one, then we will look in detail this concept. Normally we in Kubernetes we are using for example, first of all let me check OC, who am I? Okay, let me just quickly run a pod, and it's created OC get pod. Why this ran? Because I ran this with the kube admin user. If a normal user, in last video I explained that if that will not be able to run any pod that is using root user inside the container. So, but it gave us the error warning message, but allowed. Okay, so this pod is running, and now with the Kubernetes we use execute, kubectl execute, ID, name of the pod, and then namespace by default, whatever namespace is selected project, it will apply in this one, and then hyphen hyphen any command we can, and we can jump into the pod. But OpenShift introduced OCRSH. It is same like OC execute IT and then name of the pod, and then simply what command you want to run inside the pod, just like date command I want to run. Or I just want to jump inside the pod, I can use bash. So I jump into the pod. So you can see both are doing the same job. So this was a new command we can use to directly jump into the pod. Now, the second concept we have to understand the using the certificate authority built in inside the cluster to generate the signed certificate. Before that, I will explain you, or I already explained this the route concept in previous videos, but here I will again explain OC create route hyphen hyphen help. You know better how the route is working. You can see the previous videos, but routes are of three types. Okay, edge, pass through, re-encrypt. Edge is offloading the SSL certificate at the ingress controller, the reverse proxy level, and then sending the unencrypted traffic to the service and then pod. Pass through is not using the certificate at ingress controller level, but it will route the HTTPS traffic to the pod directly. Its mean end-to-end traffic is encrypted. But the responsibility of SSL offloading is removed from the load balancer. And re-encrypt is the combination of these both agent pass through mean SSL certificate will be offloaded at load balancer, the ingress controller level, the reverse proxy, whatever is used, and it will re-encrypt with the SSL certificate that is running at the pod level. It means the pod is also running on HTTPS level, and uh, ingress controller is also using its SSL certificate. So now, uh, for example, we ran this pod. Okay, we ran this pod, and we want to generate some SSL certificate that I want to apply in this pod. So I will create a service in parallel to in front of this pod, and that service will automatically generate the SSL certificate. How this is working? This is a special feature of OpenShift. This is not inside in the Kubernetes. So if I create a service with some special annotation, with this annotation, okay, and the name of the secret, any name we can define here. So this service is associated with this selector, whatever pod is running or deployment is running in front. This is the same story, but here it will create a secret that will contain the public and private certificate signed by the certificate authority of the cluster. Okay, so this annotation is specific to OpenShift that is doing this job. So I need to first of all I can create a service like this. For example, I don't have I want to apply the SSL certificate in this pod. So first of all, I need the SSL certificate. So I will delete this pod. Now, if I try to create a service by using expose command, so it will not work because I don't have any pod. So to annotate, to apply the annotate on a service, the service should be available. Or we can create our own manifest for the service before creation of the deployment or pod by using manifest. It will create automatically. So let me just create a file with a temp svc with SSL. Okay, so this will create the service name HTTPS service. Any name you can define here. Annotation is given, and the secret will create with the name TLS secret. And the selector here is HTTPS server, so we have to take care while deploying the pod or deployment to use this selector. Then it will automatically associate with the deployment or pod. And this is the port, whatever you want to hit from outside on this service that will be 443, and inside the pod it will be 8443. You can adjust these values according to your requirement. So let me just create this service. So you can see the service is created, but when I will describe service, you can see its endpoint is none because there is no deployment report so far associated with this service. And here you can see the annotation is also added. This annotation did the magic of automatically creation of secret, OC get secret, in the same project. You can see this secret is just created 36 seconds ago. And this secret, if I describe this secret, so you can see the TLS cert and TLS key is available in this secret. And these certificates are signed by the certificate authority that is running inside the cluster. So you can see this statement: the secret contain a pair signed serving certificate key that is generated by service certificate authority operator for service HTTP with host name, whatever the host name we give. So this certificate is generated. Now we can create a deployment in front of this service or a pod in front of this service that will use these certificates. So how this is possible? For this purpose, what I did, I create this manifest, and if you have an existing service that is not annotated by this for this secret creation, for an existing service you can run this command: oc annotate service, the name of the service, and then annotation. It will generate this secret with the signed certificates at the runtime. Now I have this manifest, the pod that will use the signed SSL certificate. So I created already this manifest that will do use this SSL certificate. So let me explain you. Inside the temp, I can say pod with SSL YML, and here I put all the stuff of whatever I copied. So this is the pod. HTTP server pod is the name, HTTP server pod. Okay, HTTPS server pod, and its label is HTTPS server, and this will also act as a selector. So that is we already defined in the service. And container, it will use nginx container, and this container will run on port 8443, and it will mount this secret under this location in read-only mode, so that nobody should be able to delete the secret from the pod. And this is the volume that is actually reading this secret created by the service, and both the certificate will be under this path inside this pod. And this argument we just added, it will run this bash script, the bash command at the runtime, that will generate the default.conf configuration file with this configuration, and it will override the default config file, and it will listen on this port, the private certificate, the public certificate path, and this is the setting to enable the SSL, and the web root location is same whatever is defined in the pod. So we just overwrite this nginx pod configuration file. The default configuration file is using port 80 and not using SSL. We override this setting. This is the nginx based pod, but in your scenario, this SSL certificate is usable by any application. Any web application can use this. Apache will use with the different way. JBoss will use with the different way. Okay, Wildfly will use with a different way. So uh, we have to use these SSL certificate uh, according to our application. But here I just gave you an example with the nginx. So you need to understand how you will use these certificate in your application. So this pod will run and will use this SSL certificate, and let me apply this OC apply, and this pod is created. OC get pod, it is trying to create hyphen, it's running OCRSH, this pod bash, and under what location it will create etc SSL certs. So under the etc SSL certs, the both certificates are mounted, and the config file that we generated, uh, yeah, this config file, I just want to show you what is happening inside the pod. So this will use this pod and the same certificates we used, and it will use this web root. Okay, perfect. And under this web root, by default nginx has some default web pages. Okay, now our pod is running, and OC get pod and OC get svc. Okay, and OC get secret. So these three resources we created and associated with each other. Now, if we send any request of HTTPS based to this pod, to this service, or directly to the pod, it will serve the HTTPS based traffic on port 8443. But if we send any request on this service, it will be accepting traffic for port 443. Okay, so now we will create another pod within the cluster. In any namespace we can create, but I am going to create in the same namespace, same project. See project, I just want to show you in which project I'm working, in the dev project I'm working. So I will create a simple pod, OC run, for example, client pod, and by using image is equal to nginx, get pod and hyphen o white. And one more thing, I would like to see svc hyphen o white. Yeah. So from this pod, I will hit HTTPS to this IP, and from this pod, I will hit this service on this port. So here in this pod it's 8443, and in this service it's 443. Okay, let me quickly jump into the pod, the client pod I created, and do a curl to HTTPS 8443. So here it is giving the error because the certificate is self-signed, but the concept that I gave you, it's not self-signed, it is signed by the certificate authority within the cluster. So now the question is how we can make this certificate valid for this application, because this application want to access this application on HTTPS. It should not give the error. If this will give error, the exception is not addable by the application. So we have to make sure that any pod that is trying to access the second pod on HTTPS traffic, it should be seamless, workable because this is a signed certificate. So I just add minus k, it will add the exception for the certificate. So the first thing I did wrong, that whenever you have signed certificate, you should use the fully qualified domain name. And fully qualified domain name within the cluster is only reachable by the service. So let me now hit port hit port 443 on this cluster IP. It will also give me the same error because I am using the IP. So I must have to use the by name. So the name of the service you know, is this, and uh, in which namespace we are working, the dev uh, dot svc dot cluster dot local. Just a minute, I need to apt update. I will add the ping utility. I just want to validate I am hitting the right URL or not. So self-signed certificate is done by this under this domain. apt. Okay, so I will install the ping command by using this package, and now I have the ping command, and I use this curl. So I will ping. Okay, this is perfect. So just to validate, uh, OCCAT SVC, you can see this IP is same like this IP. Okay, it's mean I am hitting the correct URL. So within the cluster, the signing certificate authority is based on this domain, cluster.local, and this is the complete child domain. So whatever SSL certificate is provided by the annotation of the service is applicable for this whole uh, fully qualified domain name. But still we are getting issue while we are doing curl to this URL on HTTPS. HTTPS, it is giving the error that certificate is self-signed, but it is not self-signed. So what is the reason? Because we this part don't know where it is signed, where is its certificate authority. If I do -k, I exclude, it will work very fine. Okay, so now we need to provide this curl command the signing authority certificate, and then it will be able to identify that these certificates are properly signed by some certificate authority. Whenever we are browsing by the on the internet some website, it is working because our browser knows all the signing authorities. That's why we are not getting the error with the signed certificate. But this is a pod, so we have to make it intelligent. So curl don't have the information of the signing authorities. So here, the another thing that OpenShift introduced, uh, we can generate a config map that can hold the certificate authority. And by default, OC get config map. Sorry, I am inside the pod. Yeah, OC get config map. So by default, OpenShift is providing in every project a config map that holds the information of let me just this OC get that holds the information of certificate authority. So certificate hyphen OYML. Sorry, Y. So this is the certificate authority. We can use with the curl command, and it will not give us the self-signed certificate error. Okay, so either we can use this config map, or we can generate our own config map too that was used that will create the certificate authority. So here I gave two commands. If I run this command, it will create an empty config map with name CA bundle. Any name you can define here. CA bundle is not mandatory. It's the name of the config map resource. And the next command will add an annotation of this in this config map that will this annotation will do the magic of automatically adding the signing authority certificate authority inside this config map. Already exist. See get config map. It was not listed here. Why it gave me the message? It's already there. Yeah, it's created. I don't know why it gave me the error, but it is created. So, but this config map, if I describe, it's empty. Okay, there is no data. So, but if when I will apply this command, these two, this is also specific to OpenShift, not in the Kubernetes. It will annotate this config map, and now you can see the signing authority of this cluster has been embedded in this config map. Now what I can do, the pod I ran, OC get pod as a client, I will delete, and I will create a new client pod that will use this config map and will save this certificate authority as a file inside the pod, and then I will use that. For that reason, what I did, I create this manifest that will create a pod that will use the CA config map. Let me VIM under the temp, I will do CA, I can say CA pod.ym. Okay, and it is CA pod. Under the temp, inside the pod, it will mount the this config map. Okay, and this is the config map. It will mount under this location. And this is again nginx I use because nginx already have curl command, or you can use any other image if you are convenient with the curl command. So see apply. Okay, I apply this and the pod is created. OC get pod. So this CA pod is created. Now OC RSH this pod bash the temp should be able to see this map CA Now curl command has a switch CA the path of the certificate, and then we can provide the HTTPS and then the complete URL of that we use to access this. Now you can see when we provide the certificate authority, it directly validate the certificate available with this URL in this pod with this signing authority. This signing authority verified that these certificates are signed by me, and you can access this URL without any error. So now think in your production environment, if you want to secure traffic within the cluster using HTTPS, there are two different applications running, and one application is accessing the another application into another pod. So you can use this way to generate the SSL certificate, and you can use in the first application that is trying to access the second application, you can provide this certificate, CA certificate, directly inside the application to validate the uh, certificate that will not give you the error. So now we understand this concept of within the cluster signed certificate. So far what we did everything within the cluster. Now what about if I want to expose get SVC, sorry, inside the pod, get SVC. So this is the service, and when I hit on this service from another pod, it's working fine. Now if I add a route, OC create route for service, name of the service is this, and just let me do hyphen help. Okay, I will use pass through. Mean don't use the ingress controller level SSL offloading directly. Send the HTTPS traffic to your application to the pod to the service. And the hyphen service is this service, and this service, and uh, in which namespace pass through. Okay, just press enter. Go see get route. So the route is exposed based on the default domain I use to create the cluster. Okay, so this URL we have to hit to access this application. So let me now just validate. I believe I add this URL in my, or I need to add in my host file to resolve this name to IP to get this application reachable from my browser. So here I will just need to move this, and from my browser when I will hit this URL on HTTPS, so it is saying that The certificate is not for this URL and not signed, and application don't know the this browser don't know which certificate authority signed this. So we can add that certificate authority in our browser to access that application, but our application is reachable on HTTPS traffic uh, from outside the cluster by using the route. Okay, and I use this a pass-through termination. So now I can also use the re-encrypt, but I cannot use Edge because Edge will send the HTTP based request back to the pod. So try this yourself by using Edge and re-encrypt. Re-encrypt, it will work. I mean, first SSL will be offloaded on the ingress controller and then it will route to the pod HTTPS. So right now just use the pass through just to show you how end-to-end traffic is working fine. So this SSL is offloaded in on pod level.